Yeah, it's not easy to pronounce the GreenBIMxEls. when we when we decided the name of the project, it wasn't our best decision. Yeah, my name is Paula Gordo, and I am a lecturer professor at Polytechnic University of Catalonia. And I need to warn you that today what I'm going to be explaining, it's like the first steps of a really big project. So it's still not finished, but still I have included like some ongoing results that I thought that could be interesting for you guys. So the GreenBIMxEls project, it's a project that it's linked to data space, but basically the idea was that nowadays public administrations are generating vast operational data, which is rarely used. They are not using it for performance monitoring or long-time portfolio planning. And our idea was to use this project based on European data spaces on the construction field to include public administrations on this and to give a use to all this data that they are producing. This is an example of some of the administrations that are working with us. This is like the beginning of the project. Afterwards, 4 administrations more joined, and nowadays we are around 12, 13 administrations in the Catalonian regional area. So about what's a data space, I think that maybe most of you already know what is it, but to define it like really quickly, the idea is to define a common governance, trust, and interoperability framework in which we can all share our information without centralizing sensitive information. So it's about federated infrastructure, interoperability framework, data sovereignty, including some analytics, and we are based on the European data strategy aligning with the Data Space Support Center, Gaia-X, etc. principles. We are addressing 3 main challenges. First of all, the need for open semantics, an open semantic framework connecting BIM, standardized data, dictionaries, and all the environmental data sets that we can get from IoT, etc. I'm just going to mention it during the presentation, but we developed our own ontology that I'm not presenting today, but I can answer about it during the questions. Then the idea is to develop some artificial intelligence-based services around this data that is connected to the data space. And we developed 3 main use cases that were addressing the needs for these public administrations that were based on energy efficiency, water consumption, optimization, and carbon footprint analysis. The methodology to creating these case studies, this is what I'm going to be explaining today, how we created these case studies, these use cases with the public administrations. So we were following the Data Space Support Center methodology with the co-creation method that was based in a first exploratory phase, a preparatory phase, and afterwards which is currently underway, the implementation phase. About the exploratory phase, we developed some participatory workshops with these administrations, with 10 of them, to identify what were their challenges and what kind of analytical services they would need to be implementing. Then the preparatory phase, we were analyzing the results, defining KPIs, and also creating a questionnaire survey distributed to 15 data consumers that could be interested on interacting with this data space. And finally, the implementation phase, which is what we're doing nowadays, that it's about pilot projects deployments and we are using real-world data sets and scenarios. Everything was analyzed. What I'm going to be presenting today, it was analyzed using text mining, co-occurrence networks, and AIR, and some other qualitative analysis. So, for the results that we found out, the key barriers identified, there were like 4 big clusters. The first one was the data sharing cluster, which we can all realize that it's the biggest issue nowadays, reflecting all the frustrations with the fragmented access, lack of data, lack of access to the data, administrations are not sharing data between them, etc. And then a problem of lack of human resources, lack of connections with research and universities, and interoperability issues. It's one of the main topics that we are addressing today on every conference. For the survey respondents, they also gave great importance to the practical and structural barriers, basically connected to the problem obtaining data in cost and time to develop services around this data. For the use case definition, so how we decided to work on these 3 topics, during these workshops with administrations, we found out that the main topic would be energy, which also makes sense. It's also the one that it's more developed nowadays. It's the largest cluster, and it's also really linked with the carbon footprint analysis. Then we realized that for the water, it appeared, but really on the peripheral nodes, and basically for leak detection and usage patterns. From the data consumer perspectives, we realized that what they were asking us was mainly simulations and predictions for decision making in design or planning, and they also needed like a confidential, secure access framework in which they could work, and that's why we were working with this data space framework. Finally, this allowed us to create our BIMxELS properties in which the ontology is based, and they are grouped in the 3 main groups of KPIs. We had the KPIs for energy, basically on pattern-oriented indicators for seasonal consumption, normalized intensities, anomalies, etc. For water KPIs, it was also based basically on consumption anomalies, use patterns. And for the carbon footprint, it was also the challenge of including regulatory compliance with all the European taxonomy, the NSH criteria, and also embodied carbon by material, circular material share, etc. This led us to develop 3 main artificial intelligence-based services, which were oriented to anomaly detection, because we found out that for energy and water were like the most important topics. And then the next step will be to start focusing on benchmarking, also comparing between similar typologies of different buildings that are not that different because they have the same typology, comparing the results, and finally working on predictive analysis. So conclusions. So basically, what we found out is that this data space allows us to create this framework, that we have a huge, robust semantic backbone based on the data from IFCs, external database, IoT, etc. We have just to find this place to connect all of them, and that it gives a value for public administrations without data centralization, and that gave these insights about their portfolio. And engineering firms also can access to validate their KPIs. For the next steps, pilot implementations, and hopefully next year I can share with you the results of these pilot projects that are ongoing nowadays. Thank you.